Hi, so today we will be talking about flash drives. Previously we talked about hard disk drives, which we sort of described as a record player with like a needle thingy, which is, reading the data from like this record. Flash, and we also talked about how this hard disk drives tends to have a really high latency, and we define latency as the time it takes to seek, essentially move between the different tracks of the HDD, so different concentric circles, the time that it takes to rotate, and the time it actually takes to transfer. So when we are talking about Flash, Flash actually does not sort of solves this problem of high latency by not having any moving parts. So this has no moving parts. Data is stored in cells, right? So charge in cells is what stores our data, and by having this, we can have much faster latencies, and we can essentially eliminate the need for seek time and rotate time. So Flash is actually made up of a bunch of cells with charge. So we have single level cells, which is sort of divided in half. Essentially, if the charge is below a certain threshold, then the charge is 0. If the charge is above a certain threshold, like this, then the charge is equal to 1. So this is the line which sort of divides the bits. And then we also have multi-level cells, right? And then these are divided up into smaller subsegments. And it's similar concept to this. Basically, the lowest level represents bit value 0, 0. The second layer, if it's filled up to the second layer, it's equal to 0, 1. If it fills up to the third layer, it's 1, 0. Fills up to the highest layer, it is 1, 0. So the one problem that Flash has is that these cells tend to wear out really fast. Basically, this constant movement of charge up and down, right? And especially in multi-level cells, right? Because you have more precise movements to get to each of these levels. They tend to wear out incredibly fast. So when you're deciding whether you want to use a hard disk drive or a flash drive, so that may be something that you want to, keep in mind and take into account. Depending on your particular use case, you may want faster rotates, but you don't really care if these accesses, if like the flash drive is wearing out. But on the other hand, if you're looking for something more long-term, maybe you would want to go for a hard disk drive so that it doesn't get worn out too much. So moving on, so a cell or the overall drive is split up into subunits called banks. So these are banks, right? So it would be like this, and then each bank is in turn made up of smaller subunits called blocks. Oops, I will get tired of drawing. And then in turn, each of these blocks are made up of pages, and I'm only going to draw one. So each of these blocks, so I'll color one in, right? So this is the flash, and then the flash is made up of, let's just say, 4 banks, and then if you zoom into the banks, then you get blocks, and if you zoom into each block, you get a bunch of pages. And when we talk about Flash, the other reason that it's fast is because of parallel reads that it can do, and this parallelization is done in the level of banks, so you can read bank 1 and bank 2 at the same time. So when you're talking about parallel actions or parallel reads, it's at this level right here, not at the lower levels. So right, so moving on, so the main thing I want to go into is like reading and writing two flashes. If you want to read something, right, you just follow the hierarchy down, like, oh, I want to read something, it's at this position right here, so I'm going to first go to this position, go to this bank, then I'm going to go to this block, I'm going to go to this page, and then say this is the value that's there, 0, 1, 0, and I'm going to retrieve the 0, 1, right? Writes are a little bit more complicated, simply due to the nature of the way Flash works. So if I want to write, say, 1, 0, like I just want to flip the bits in this exact position, right? I'm going to go to the correct bank, I'm going to go to the correct block, I'm going to the correct page, and I'm going to expand on the page, and this is what I see, right? So let me actually redraw it, right? So this is inside our page, it has our data, and we can just assume this is like a multi-level cell, and then this is what it's holding, and I want to make this value 1, 0. So what are we going to do? So due to the nature of Flash, we can't actually just cross this out and then say, oh, I want 1, 0 now. I can't just, you know, like fill it up with a little bit more charge and then bump it up to 1, 0, right? What we actually have to do is we have to erase this block. And what does erase mean? It means, it basically means like filling it up with charge and making all the values 1. So making all the values 1. And when I say make all the values 1, it does not mean just the ones in this part of the page. It means the entire thing, right? And that's the problem. So what we're going to have to do is first we have to copy this into memory, and we're going to remember that, oh, this is the data that we had, and then we're going to erase it. You have to erase every single thing and make it all 1s. And then when it's in memory, you can change this to 1, 0. And then now you can take this new updated data and then put it in here. And then you can modify it from here. So you can have 1, 1, 1, 0, 0, 1, 1, 0. And that's how you would want to update or do a write action. Like you have to update everything in the block just so that you can modify one tiny segment. And this is also, like we were talking about, how Flash wears out quickly, and since you're constantly having to rewrite to the entire block, this again makes Flash wear out even more. So random IO is actually not good at all for Flash. It wears them out a lot faster because it does not support any in-place changes. The only workaround to this is to check if you have a free block. So basically, instead of modifying this original block right here, right, what you can do is you can check, oh, does this block have any empty space? Because if this block looks something like this, instead of overwriting this block, you can just directly modify this block. So you can copy this block into memory and then modify it and then assign this new block to this other block, and then you just have to make this, the old block, set it to invalid, and then eventually another process will come and will do this clearing up process for you, but you don't have to do it immediately. So you'll prevent, or especially if you're writing to this one page a lot, suppose you don't want to constantly keep erasing it. So you can just keep using new blocks to store your data. And then internally you would have to change the mapping. Of course, like you would have to say, oh, we actually have to go down this path and then go to this block, and then modify it. But this is one option to mitigate that. So yeah, that was Flash.